So in the last video, we talked about critical points, and critical points, as a reminder, are places where the derivative is equal to 0 or where it's undefined. In this video, I'm going to do a couple of examples for you to show you how to find those critical points. Before we start, I want to go over the definition of critical points just because there's a small subtlety that you should be aware of. It says, let C be an interior point in the domain of F. We say that C is a critical point of F if F prime of C equals 0 or F prime of C is undefined. All right, and the key that I want you to be aware of is that it says that C must be in the domain. All right, so that means that the original function should be defined at that point C. All right, so let's go ahead and look at a couple of examples. The first example is f of x equals 4x cubed minus 3x. And if we want to find the critical points, we're trying to find out where f prime of c is 0 or where it's undefined. So we'll need the derivative. So f prime of x is equal to 12x squared minus 3. There's no place where that is undefined, and so all we need to do then is to set it equal to 0 to find the points where it's equal to 0. And so now we just solve for x, so I'm going to add 3 to both sides, so I get 12x squared equals 3. I'm going to divide both sides by 12, so I get x squared equals, that's 1/4, right, if we simplify. And then I take the square root of both sides, and remember when we take the square root we have to have the positive and negative root, so it's the square root of 1/4, which is positive or negative 1/2. So I have a critical point at negative 1/2, and I have a critical point at positive 1/2. All right, and all we're trying to do at this point is to identify the critical points. Again, this does not guarantee that we have a maximum or a minimum at that point. All right, the second example that I want to look at is f of x is equal to x plus 1 over x. And so, again, let's take the derivative. F prime of x is equal to, we can do this a couple of different ways. We could have combined these terms at first by getting a common denominator, or we can just take the derivative of each term separately. I'm going to go ahead and write this original function as x plus x to the negative 1. All right, we brought this up to the top and wrote it as x to the negative 1. Now I'm going to take the derivative. The derivative of x is just 1, and then the derivative of the second term is minus 1 x to the negative 2. So simplifying, we get 1 minus 1 over x squared. All right, so this is our derivative, and we want to think about where the derivative is equal to 0 and where the derivative is undefined. And so let's consider first where the derivative is undefined. We know that this derivative would be undefined at x equals 0, wouldn't it? X equals 0 would make that undefined. However, if we look at the original function, we know that 0 would make the original function undefined as well. So x equals 0 was not in the domain of f. It was not in the domain of the original function. So therefore, x equals 0 is not a critical point. Again, even though f prime of 0 is undefined, since 0 was not in the domain of the original function, 0 is not a critical point. So the last thing we need to do then is we need to set f prime of x equal to 0, right? So the only other place that we'd have a critical point is where the derivative equals 0. So I'm going to set this equal to 0. And I'm going to solve for x. So I'm going to add 1 over x squared to both sides. So I get 1 equals 1 over x squared. I'm going to multiply both sides by x squared. So these cancel, and I get x squared equals 1. And so that means x equals plus or minus 1. What I did was take the square root of both sides, and we needed the positive and negative root, so we get x equals plus or minus 1. So my two critical points are x equals positive 1 and x equals negative 1.